Here we'll quickly say what coefficients are. They come up a lot in algebra. First, suppose I tell you the variable x equals 2 and the variable y equals 5. Then evaluate this expression, 3x plus 4y, or click down here to review. Right, this equals 26. Now in this expression, the numbers 3 and 4 are coefficients. Coefficients are numbers that appear in front of variables. To be more precise, they're multiplicative factors in front of variables, which means they're numbers that you multiply variables by in expressions. So x is being multiplied by 3, and y is being multiplied by 4. So 3 and 4 are the coefficients here. Okay, so take a look at this expression here. 2a plus 7b plus 9c. What's the coefficient for the variable b in this expression? Exactly, 7 is the coefficient for b. In this expression, b is being multiplied by 7. Next, go ahead and identify all the coefficients in this expression. 3p plus 5.2q plus 7/9 pq. Nicely done. 3, 5.2, and 7/9 are the coefficients here. Now for the expression 2x plus y, the coefficient for x is 2. But what about y? There's no number in front of y. Whenever you have a variable by itself like this, with no number in front of it, the coefficient is actually 1, because y is the same thing as 1 times y. So let's look at the expression a plus 4b plus 2c. What's the coefficient for the variable a in this expression? Right, the coefficient for a is 1. Now what happens when you have a minus sign in your expression, like 6x minus 3y? Well, subtracting 3y is the same thing as adding negative 3y. Click here if you want to review why that's true. So the coefficient for y is negative 3. Try another example of this. In the expression 4a minus 8b plus c, what's the coefficient for the variable b? Right, we're subtracting 8b here, or adding negative 8b. So the coefficient for b is negative 8. For your final challenge, take a look at this expression, 3f minus 9g minus h. What would you say is the coefficient for h? This is tricky, so feel free to ask for a hint if you need it. Nicely done. There's no number in front of the h, but it's the same as 1h. And subtracting 1h is the same as adding negative 1h. So the coefficient for h is negative 1. Great, so now you have some experience identifying coefficients in algebraic expressions. To get started, suppose the variable x equals 5. Then evaluate this expression, 3x plus 4x, or click down here to review. Right, if x equals 5, then 3x equals 15, and 4x equals 20, so adding them together gives you 35. Now which of these other expressions down here is equivalent to 3x plus 4x? When x equals 5, which of these also equals 35? Right, 3x plus 4x equals 7x. And not only is this true when x equals 5, for any value of x, 3x plus 4x always equals 7x. Let's see if we can figure out why. Well, 3x is the same as x plus x plus x, and 4x is the same as x plus x plus x plus x. Adding them together, we have a total of 7 x's here. So this equals 7 times x. No matter what x equals, 3x plus 4x equals 7x. Another way to see this is true is with the distributive law. 3x plus 4x is the same thing as x times 3 plus 4 in parentheses. If you distribute the x onto the 3 and the 4, you get 3x plus 4x. So these two expressions really are the same. And 3 plus 4 is 7, so this equals 7x. In general, you can always combine like terms. Like terms are terms that have matching variables. In this example, both terms have the same variable x. Whenever you're adding or subtracting terms with matching variables, you can combine the terms by adding or subtracting their coefficients, which are the numbers in front of the variables. So to add 3x and 4x, you can just add 3 and 4 to get 7, and then remember to include the x. Try another example. Which of these expressions is equal to 2y plus 7y? Excellent! So for any value of y, 2y plus 7y will always equal 9y. Next, take a look at the expression b plus 5b plus b. Which of these is an equivalent expression? Nicely done. When a variable is by itself, like b over here, that's the same as having 1b. So we have 1b plus 5b plus another 1b. 1 plus 5 plus 1 equals 7. So this is equivalent to 7b. For any value of b, like -6, 0, or 17, these two expressions will always give you the same result. And how about this expression, k minus 6k? Which of these expressions is equivalent? Precisely, the coefficient of this k is 1, and 1 minus 6 equals -5, meaning this expression equals -5 times k. Next, let's look at an expression with two variables in it, 2a plus 5d. The variable a is equal to some number, but the variable d can be equal to an entirely different number. So these are not like terms. They have different variables and cannot be combined. Now what if we were to add 6a to this expression? So now we have 2a plus 5d plus 6a. How can we simplify this expression? What's a shorter but equivalent way to write this? Nicely done. The like terms are 2a and 6a, and adding them together gives you 8a. Meanwhile, you can't combine 5d with any other terms, so this is the simplified expression. Now how about this one? 4x plus 9y plus 2xy minus 3y. So now we have a term with variables that are being multiplied together. How can we simplify this expression? Well, again, we look for like terms, which have matching variables. First, we have 4x. Any other terms with just an x? No. 9y. Any other terms with just a y? Yes, we're subtracting 3y. So 9y minus 3y equals 6y. And then 2 times x times y. Any other terms with an x and a y? No. So this is the simplified expression, 4x plus 6y plus 2xy. So for your final challenge, take a look at this expression down here. Which of these are like terms? Which of these can you combine? Right, these three terms can be combined. The order of the a and the b in this middle term can be switched, since you can multiply them together in any order. So to simplify, we can combine 7ab plus 5ab plus 4ab to get 16ab, because 7 plus 5 plus 4 equals 16. So this expression equals 16ab minus 3bc minus 2c. Let's look at the equation x minus 5 equals 7. Suppose we want to solve for x. That means we want to do something to both sides of the equation so it says x equals something. So what can you do to both sides of this equation to solve for x and get rid of this minus 5 on the left? Okay, let's add 5 to both sides. On the left we have x minus 5, then plus 5. Subtracting and adding 5 cancel out, leaving us with just x on the left. So nicely done. And on the right side we have 7 plus 5, which is 12. So by adding 5 to both sides of this equation, you solved for x. It's 12. Next, let's look at a slightly more complicated equation. 3x plus 4 equals 10. So now the x is being multiplied by 3, and then we're adding 4. So how can we solve for the x here? Well, we can do this in 2 steps. First, let's try to get the 3x by itself on the left side of this equation. So what can we do to get rid of the 4? Okay, let's subtract 4 from both sides. On the left, we have 3x plus 4, then minus 4, so the 4's cancel out, leaving us with 3x. Perfect. And on the right, we have 10 minus 4, which equals 6. Okay, so now let's try to solve this simpler equation. What's the next step we should take so we have just an x by itself on the left side? Alright, let's divide both sides by 3. On the left, we're taking x, multiplying by 3, and dividing by 3. So the 3's cancel out, leaving us with x. Nicely done. And on the right, we have 6 divided by 3, which equals 2. So the solution to our original equation is x equals 2. Let's double check that by plugging in 2 for x. That gives us 3 times 2 plus 4 on the left. 3 times 2 is 6, and 6 plus 4 is 10. So yes, 2 is the correct solution to this equation. How did we get that? We simplified step by step. First, we subtracted 4 from both sides to get rid of this 4 over here. Then we divided both sides by 3 to solve for x. Try using this step-by-step approach on another equation. 4y minus 9 equals 15. Can you solve for y? Exactly, so y equals 6. Alright, now for a slightly tougher equation. Y divided by 4 plus 3 equals 8. Again, try using a step-by-step method to simplify this equation until you get a y by itself on the left. Nicely done! There were a few different ways you could have solved this. One way is to first subtract 3 from both sides. On the left, the 3's cancel, leaving you with y over 4. And on the right, 8 minus 3 equals 5. Then you can multiply both sides by 4. On the left, you get y, and on the right, you have 5 times 4, or 20. Now, you could also have solved this another way. Instead of subtracting 3, let's first multiply both sides by 4. So on the right, we have 8 times 4. And on the left, you might be tempted to multiply by 4 like this. But this expression says you're just multiplying the first term by 4, and we wanted to multiply this whole expression by 4. We can do that by putting it in parentheses. Then we can distribute the 4 onto the sum. 4 times y over 4 gives you y, and 4 times 3 equals 12. And on the right, 8 times 4 equals 32. Then, to solve for y, you can subtract 12 from both sides. Once again, this gives you the same correct answer of 20. Okay, next, try an example where the variable is being multiplied by a negative number. Negative 2a plus 6 equals 20. Solve for a. Nicely done. So a equals negative 7. Next, let's look at an equation with a fraction. 2/9 x plus 7 equals 3. First, let's get rid of this 7 on the left by subtracting 7 from both sides. So on the left, we now have 2/9 x, and on the right, 3 minus 7 equals negative 4. Now, what can we do to get rid of this 2/9? Well, you may remember from multiplying fractions that it might be a good idea to multiply both sides by the reciprocal, 9/2. If we do that, then on the left the 9's cancel out and the 2's cancel out, leaving us with just x. On the right, we now have negative 4 times 9/2, which equals what? Excellent, so x equals negative 18. Let's quickly double check that answer. If we plug in negative 18 for x, is this equation true? Well, 2/9 times negative 18 equals negative 4. And sure enough, negative 4 plus 7 equals 3. So this checks out, and negative 18 was the correct answer. Alright, now try another equation with a fraction. Solve this equation for y. Excellent work! We can start by adding 5 to both sides. That leaves us with 4/3 y on the left. and on the right, 7 plus 5 equals 12. Then we can multiply both sides by the reciprocal of 4/3, which is 3/4. These two fractions multiply to 1, so on the left we have y by itself. And on the right, 12 times 3/4 is 9, so y equals 9. Next, take a look at this equation. 2y plus 18 equals 5y. So now we have two terms with the variable y. To get started on this equation, let's combine the like terms, the 2y and the 5y. We can do that by subtracting 2y from both sides. On the left, we now have 18 by itself, and on the right, we have 5y minus 2y. Can you simplify this expression? Which of these choices down here is equivalent to 5y minus 2y? Right, 5y minus 2y equals 3y. So that means 18 equals 3y. To solve for y, we can divide both sides by 3. These 3's cancel, leaving us with y. And 18 divided by 3 equals 6. So y equals 6 is the solution to this equation. Try one more example. 2x plus 8 equals 7x minus 4. Try solving this one step at a time, and you should start by combining the like terms. Excellent work! One way to solve this is to first add 4 to both sides. So on the left we have 2x plus 12, and on the right we have 7x by itself. Then, to combine the 2x and 7x terms, we can subtract 2x from both sides. On the left we now have 12, and on the right we have 7x minus 2x, which is 5x. Finally, to solve for x, we can divide both sides by 5. So x equals 12/5. And that's equivalent to 2.4. When you're solving equations, there's usually some division involved, so don't be surprised if you get fractions or decimals in your final answer.